In this presentation, we're going to look at the power set. So as an exercise, what we're going to do is determine the power set for the following set A, which comprises the four elements P, Q, R, and S. The power set of A, denoted by P of A, with this very distinctive P, is an exhaustive list of all subsets of A. Now just to be clear, exhaustive list means that we have to find each possible subset. The empty set and A are two such subsets, so A is a subset of itself. So, important point to start off with, the cardinality of set A is 4. That is to say, there are 4 elements in set A. So the cardinality of the power set of A is going to be 2 to the power 4, i.e. 16. So I've set up this table here to provide a very structured approach to what we're going to do. Now, as I said before, we've already found the empty set and set A. So what we have here is the subsets of the various sizes. So we know that we could have a subset of size 0, which is the empty set, and there's going to be one of those. And we have a subset of size 4, which is A itself, P, Q, R, and S, and we have one of those. I'm going to describe how we get these other numbers later on. But just a remark, the subsets we have to find are subsets of size 1, of size 2, and of size 3. We'll start off with a very simple group of subsets, and we're the subsets of size 1. All we have to do here really is just pick out each individual element of A and class that as a possible subset. So we have P, Q, R, and S. So we have 4 more there. The next thing we're going to do is consider what would happen if we selected P, what gets left in A. Well, consider that Q, R, and S will get left. And what we can do is consider that as another possible subset of A. So just think of what gets left over when we take out each of these values here. And we would get Q, R, and S, P, R, and S, P, Q, and S, and P, Q, and R. Okay, and we've found 4 more there. So that just leaves us 6 to find, and these are the subsets of size 2. So what we have to do is go through them quite thoroughly. P and Q, P and R, P and S, Q and R, Q and S, and R and S. So that's all 6 of them there. And that means we have found all 16 possible subsets. So what we're going to do now is actually just write them out formally. The power set of A is written out sort of like that. It's not the easiest thing to look at, but so when you have a sort of structured approach like the table I used previously, I'm just going to slide back there, it makes it easier to sort of figure out what you're doing. And finally, just as a remark, the number of subsets of each size k are binomial coefficients. So if you're familiar with binomial coefficients, that's how you would automatically know that this is 1, 4, 6, 4, and 1. If you don't know what they are, not to worry. I won't get into them now.